One of the special things about alkenes is that they have a type of isomerism called geometric isomerism. That's to do with how the atoms are arranged in space. And it occurs because it has a carbon-carbon double bond, which prevents rotation. Now, what do I mean by rotation? In a carbon-carbon single bond, this carbon can rotate with respect to this carbon. It's a bit like this toy here, where I can rotate this around to show different perspectives of the same thing with relationship to this one here. So it's a bit like that. This is rotation. And when you do that, what you see is different. So for example, these red dots that represent different atoms or different carbon chains or different functional groups, when they get rotated, they're in a different position, but it's actually still the same molecule as the one there. However, an alkene has a double bond, and this won't allow for that rotation. So these two molecules would be different. So we can see that these two are identical on the left-hand side, but different on the right-hand side. If you were to draw right there formula, it would be green, black, carbon, carbon, red, blue, and it'd be the same for this one. They'd have the same molecular formula and same condensed structural formula, but their expanded structural formula looks different. The best example to use, or the best case study to use to show this, is 2-butene or butene. So here we've got the condensed structural formula of butene. We know it's but because it's got 1, 2, 3, 4 carbons. We know it's an ene because it's got a carbon-carbon double bond here. And we know that it's 2-butene because 1, 2, 3, 4, or 1, 2, 3, 4. The lowest carbon that it's on is number 2. But if I draw the expanded structural formula, I can see that there's two ways to arrange those atoms in space. And because I can't just twist or turn like I can with a single bond, then these two are actually different. And one would be a higher density than the other. We could pack the cis ones together a lot more tightly than the trans, for example. So when I'm going to look at the carbon chain only for what we're doing this year. So we're going to be following the longest carbon chain. When the longest carbon chain is all on one side of the double bond, we can draw a letter C. If you look 90 degrees around, it looks like the letter C. So it's the prefix CIS. So it's cis-2-butene or cis-butene. They're both equally correct. Interestingly, the old way of writing these was using a Z or an E. So this used to be called Z-butene, and the Z comes from the German zusammen, which means together. So just an interesting note on that one. The opposite to cis is trans. And if we think of words that we know that have got trans in them, so to transit is to go through somewhere, so the transit lounge, for example. So trans meaning to go through. So if the carbon chain goes through the double bond, as you can see the arrow showing there, then it's a trans isomer. So it'd be trans-2-butene. And again, the old name for this would be E-butene, and the E comes from the German entgegen, which means opposite. Opposite sides of the double bond. So geometric isomerism occurs because there's no rotation around the carbon-carbon double bond, and because there's two things on each carbon, it means there is the possibility, because it doesn't always happen, it means there is the possibility for having cis, where the carbon chain is all on one side of the double bond, or trans, where it goes across the double bond.